Andrew Neal. This is homework 6, part 1, test bench. As you can see my code here, I had to import component top level ALU and its inputs and outputs. I also had to import the component ALU and the FSM for the op line or the state select to work for me to display it. I created a signal right here, state select, which I'll show you later on. It's a 2-bit. My signals are X, Y, reset, clock, top level output, which is all in my top level component. I have my clock period. Here's where I'm mapping everything. Remember the signal state select? I had to bring in components ALU and the FSM to get the op line and the FSM output tied together in another signal called state select. So therefore I had to map input or output to input, reset clock, state select, which would have been the FSM output, is now state select. ALU map is XY, which is the top level inputs now, and the op line is state select map now, and the top level output is mapped to the ALU output. Here I'm just instantiating everything to itself, processing the clock period, and then here are my initial values set, and as my program begins, it starts off, or if the reset is 1, it waits 100 nanoseconds. Reset is 0, then clock is equal to 0, waits, then it sets clock to 1, and then it just cycles clock on and off, and it just shows you the different states. As we step over here to run the simulation, I will show you. Let me zoom in so you can see. Okay, so we'll run a couple states here to show the different. And reset hit 1. Okay, so we'll step in here. Okay, so my two inputs are 0010 and 0011. This will show state 0. Those will be ANDed together, so that would be the output. If reset drops to 0 and clock goes to 1, it goes to next state, which is showing whatever operation that is in my ALU, which would be OR operation. Then it goes to the next state, 10, which is the NAND operation, and then when reset hits 1, it resets all back to 0.